Welcome back, folks. Here's another one, and here's why I like mesh analysis. It scales. We can make it bigger. If I put this circuit up here for you, it's right behind me here. There it is. If I put this circuit up on a board, and it was even a week ago, however long this is taking you to move through the videos, you might have just dropped the class. I don't want you dropping the class. I want to get you to the point where you can analyze any circuit. And mesh analysis is one way to do that. We want to find VO. If I had to play the game of what's in series, what's in parallel here, maybe I could do it. I've never even thought about it for this problem. Ooh. But why would I do that when I have mesh analysis? Okay, I have 3 meshes, and that's going to give me 3 unknowns. And right now, we're still only writing KVL equations. That's our default equation. So adding a third mesh is as simple as just adding a third equation, making the matrix 3 by 3 when we go ahead and solve it, and we're going to get 3 mesh currents. And then we're going to use those 3 mesh currents to find VO. Okay, once again, I already had these labeled. I don't have a clean figure without the labels on them, but I labeled the mesh currents. I labeled them all clockwise, and then I used the passive sign convention to label the polarities. So if I'm moving clockwise, I go plus, minus here. That's an active component, so I skip it, plus, minus there. Okay, moving over to the yellow, I'm working around this way. Right, they're all passive, so this is plus, minus, plus, minus, plus, minus. Coming up here, I'm going clockwise again. I'm moving around this direction, and plus and minus for that passive element, and plus and minus for that passive element. Again, this is active, so it's always going to be positive on the long bar, negative on the short bar. Doesn't matter which mesh you're approaching it from. Its whole purpose in life is to create a 6-volt differential between the 2 terminals. This one's going to be 6 volts above this one. All right, so let's do it. Let's write some KVLs. And let's start out with I1. We've got 3 elements in it, and we are going to have 3 terms in our KVL. So from here to here, I'm going to go down. Come on, give me the color I want. I'm going to go down VR1. From here to here, I'm going to go up V1. And from here to here, I'm going to go down VR3. Okay, we're back to where we started, so that's equal to 0. Looking at our currents, that's the positive current direction there. That's the positive current direction for this polarity. So it's going to be negative I1 R1 plus V1. The minus is going to come down, and I'm going to have I1 minus I2, and that's flowing through R3. And that's equal to 0. We can start to move a little quicker, but you still got to think about where all of these things came from, because if there's ever any question about signs, you go back to where these variables came from and how the original application of KVL, KCL, and Ohm's law was carried out to get the signs. Okay, regrouping all of this, we've got 2 terms in front of R1 if I distribute this. So if you get comfortable and you can distribute things and regroup, then you don't have to write it as much. Just make sure you get the right answer. If you can't, go ahead and write out each individual term, and you'll be in much better shape. Okay, so I have negative R1 and negative R3 in front of I1, and then in front of I2, let's see, that minus cancels that minus. I get plus R3 I2. All right, the only thing left is this V1. We're going to pull that over to the other side. It's going to become negative V1. All right, so that one's in good shape. All we got to do is plug values in, and we have negative 9K and negative 6K. So we're going to get negative 15K in front of I1 and plus 6K in front of I2. And where's V1? That was V1. 6 volts. Okay, so that's going to be -6 on that side. I'm going to go ahead and box that. Right, that one's ready to be included in my system of equations. Oops. Can I get it back? There we go. Okay, doing the same thing for I2. So let's grab our yellow color so that it lines up. Most of the time I label these because I don't have all these fancy colors, and I would say that's the KVL for I1. Okay, the KVL for I2 is going to be, let's see, I'm going to drop across R3, so it's going to be minus VR3. I'm going to drop across R4, so minus VR4. And I'm going to drop across R5, so minus VR5, and that's equal to 0. Plugging things in, now I'm using the yellow polarities, right? So the positive direction for current is going to be that direction, and that direction. Okay, so the negative comes down, and I2 flows in the positive direction, and I1 flows in the negative direction through R3, multiplied by R3. The negative drops down. Careful with R4. Remember, we have I3 up here. It would have been easy to just neglect that. Oh, now the equation's behind my head. So I3 goes in the I3 goes in the negative direction. I2 goes in the positive, right? So let me get this up where you can see it. And we're going to say I2 minus I3, and that's in front of R4. I've run out of room over here. I'm going to have to wrap my equation. Sorry about that. And we have minus I2 R5, and that's all equal to 0. Okay, so that's looking pretty good. We just have to rearrange our terms, so distribute and regroup. So it looks like I've got an I1 term here, and it's going to be positive R3 in front of I1. In front of I2, I have negative R3, negative R4, negative R5. That's in front of I2. All right, and then in front of I3, the only I3 I have is here, and we're going to have positive R4 I3, and that's equal to 0. So double check me. Always double check my algebra. Always double check my arithmetic. You should do that for yourselves as well. All right, plugging in some values. We're going to get 6K. Let me scroll up a little here. 6K I3. 6K I1. What did I just get finished saying? Always double check me. Negative 24K I2. And positive 6K I3, and that's equal to 0. So there's our second equation. Okay, I think we're in good shape there. Let me just double check myself. Trust but verify, right? Okay. Last one. What color do we have? We have a darker blue. And we're going to have 3 terms. Let's start over here. We're going to drop across VR2. I'm going to write it up here and then move it down. Drop across VR2. I'm going to drop across VR4 as I come back here. And now I'm going to go from positive to minus. So I'm going to drop across V1 in this case. And I'm back to where I started over there. And I'm equal, since I'm back to where I started, it is equal to 0. So let's grab this KVL and bring it down over here. Okay, so here's the KVL for I3. Okay, VR2. The only current flowing through it is I3, and it flows in the positive direction. It's going to be I3R2. Bring the negative sign down. VR4. I3 is positive in this case, and I2 is negative. Check the current direction on that. Think about the passive sign convention, and I'm using the plus or minus that is labeled around VO. because it agrees with passive sign convention for the direction of I3. Okay, and then let's see, minus V1. Oh, I forgot a resistance there, didn't I? This is going to be times R4, and then minus V1 just comes down, and that's equal to 0. Distribute, regroup, get it in the form that we need it. I don't see any I1 terms, so my I2 term is really here. So I get R4 I2 as I distribute this negative sign and that R4. And we get negative R2, negative R4 in front of I3. And then V1 moves over to the other side, and it becomes positive when we do that. Okay, so not too bad. Plug in some values. R4, 6K I1, I2, minus R2 and R4. What do we got for that? 4K and 6K, minus 10K I3, and that's equal to V1, and V1 is 6. Okay, so let me just double check myself on that one as well. I think we're looking good. Yeah. Okay, so these three equations are what we need to form our system of equations and to ultimately find the mesh currents. So let me bring them all down here. Oops. Bring them all down here. Okay. It doesn't matter what order you put them in the system in the matrix, right? Because you're just rearranging the order of the equations. You're not changing any details about them. Okay, so that's my system of equations. I jumbled them up. It really doesn't matter. Your mesh currents are going to come out in the same order because it's the order of the coefficients that's important. Okay, so let's do this. I think I have enough room to do all of that. Yeah, let's just start up here. So what's the coefficient of I1? All right, some of you have already yelled it at your screen. Some of you are still looking at that equation. But that's the first one we're going to start with because that's the order of our coefficients here. I1, I2, I3. So they're in rows over here, but ultimately they're going to be in columns. Okay, so it's going to be I1, I2, I3. It matches the order down here. Okay, so what's the coefficient of I1? There is no I1, and so the coefficient we enter is 0. Okay, coefficient of I2 is 6K. Coefficient of I3 is negative 10K. And we got 6 on the right-hand side. Okay, playing the same game down here, we have negative 15K as a coefficient of I1, 6K as a coefficient of I2, 0 as a coefficient of I3, and negative 6 on the right-hand side. Moving down a little further, we have 6K in front of I1, negative 24K in front of I2, and 6K in front of I3, 0 on the right-hand side. Okay, so grab a calculator, grab MATLAB, whatever you want to do, but there's our system of equations. I'm going to grab my 85, and it's a 3 by 3 matrix, right? So I'm solving for 3 unknowns, 0, 6K, negative 10K, 6, negative 15K, 6K, 0, negative 6, 6K, negative 24K, 6K, and 0. And hopefully I agree with Past Dave. Past Dave agrees, so we're in good shape there. Okay, so from that system of equations, I get 373.33 microamps. I get negative 66.67 microamps. And I get negative 640.0, I guess, microamps. Okay, there are my mesh currents. That's great. We're almost there. Oh, that's behind my head. Okay, there are my mesh currents. That's a good start. What we were after is V out. So I'm going to play that same game. I'm going to scroll up to the schematic, going up. There we go. And we want to find V out. Okay, it's a voltage. So I'm looking at that polarity. Because that's labeled V out, I'm going to use the polarity that matches that label. And that tells me that the positive current direction is going to be right to left. So if I want to find V out, I1 doesn't touch it. I2 does, but goes in the negative direction. And I3 touches it and goes in the positive direction. And then I multiply by R4. So that's going to be my equation for V out. Now I just got to plug in some values. Let's do that down below where we have everything all in one place. Okay, so come down here, and there's our equation. Okay, V out is equal to negative, what's I2 here? Oh, we've got a negative in the, it's right there, right? So we got to pull that negative sign in as well. Negative 66.67 microamps. And we're adding I3, so it's going to be plus a negative 640. I'm going to drop my decimal point. Forgive me for significant figures. Okay, so we've got to make sure we plug in those negative signs along with it. And then R4, where is R4? Is a 6 kilo ohm resistor. So if you plug that all in your calculator and you hit enter or equals or whatever you need, you get negative 3.44 volts. Okay, and there's your answer. So it scales. It scales. It's fantastic. Okay, if I add another mesh, I just add another equation and I write it in the same way, and my matrix just gets a little bigger. There might be some practical limits, but you're not going to hit them. Okay, we're talking thousands upon thousands of meshes. We might run into some mathematical limitations, but we're going to be okay with the problems that we work here. Okay, so it scales. What we haven't dealt with is current supplies, and we're going to learn how to do that in the next video. So stay tuned and good luck.